Well, g'day everyone. Glenn Morris here from the Smart Energy Lab. And today in the lab, I've got a guest all the way from South Africa. It's like 8 a.m. in the morning over there. So he's up early and bright. So welcome, Jon.
Thank you, Glenn. It's such a pleasure to be talking with you.
Cool. Well, as my audience probably know, I was actually over in South Africa recently learning about renewables in the South African context. And I came across your team there and discovered that you have some very exciting products from your company called Plentify. Tell me a bit about Plentify.
Yeah, of course. So at Plentify, we build a home energy management system. What that means is that we'll help your appliances use as little electricity as possible. And the electricity that they do use, shift as much of it as possible to solar. Ultimately, the problem we're trying to solve is that solar is the cheapest form of generation in history, but it shines at the wrong times. So rather than filling up a battery and then using that battery to fill up your appliances, why not just shift your appliances to use the solar directly and do it for 75% cheaper?
And how do you do that?
So we've built a modular system that has lots of devices that plug onto various appliances in your home. We've got two products in the market at the moment. There's HotBot, which attaches to your water heater or your geyser, and SolarBot, which attaches to your inverter. In addition, these products can talk to APIs in your home to control other load platforms. And it's basically understanding the state of solar in your home, understanding how much solar is going to be generated in the future, how much demand each of your appliances is going to want to use, and figures out how to allocate that energy effectively across your home so that you get the services that you want when you need them.
Right. So it's more than just a simple, turn on your hot water system. It's a smart energy manager.
Yeah, exactly. I mean, on the water heating side, for example, most existing products would be simple, smart on-off switches. So you might, from your phone, turn your water heater on or off, or set a timer that turns the element on and off at specific times. The problem is that's not really how you live your life. If you want a hot shower at 7 p.m., you don't want to have the headache of trying to figure out how far in advance to turn on your water heater to make sure you have hot water at 7. Nor do you want to sit next to your distribution board or your timer all day, turning it on and off to make sure that you take advantage of those moments in the day where you happen to have surplus solar. So HotBot and SolarBot solve that together by firstly letting you define when you want hot water, not when you want the water heater to turn on, and then running a bunch of optimization algorithms to turn it on at the best times for you to drive savings and solar self-consumption.
Now, just for a bit of an explainer here, I noticed at the beginning you referred to this device called a geyser. What is a geyser?
Yeah, it's a term. I don't know where it came from. I think it's probably from our UK colonial heritage or something, but geyser is the colloquial term in South Africa for an electric water heater. It's not a thermal geyser or geyser. It's not an old person. But yeah, it's quite interesting when I talk to international folks. I often make the mistake, and they get very confused.
It's all great. Every country has its variations on things that we think we all know. It's just another fun one.
Totally. Now, Australia's, I think, the winner there. You guys have got the most interesting local jargon.
I don't know. South Africa was pretty interesting too. I learned what a braai was, and that's pretty culturally important. Yeah.
Absolutely.
Yeah. Hey, so I've got two of your products here. Thank you for sending them to me. And I thought I'd actually get you to tell us a bit about them as I show them. So I've actually got a little overhead camera where I can bring up the HotBot, and I'll ask some questions and you can just kind of explain it to me. Is that okay?
Absolutely.
Okay, well, let's just do that. So here we go. This is the box that the HotBot comes in, and it's a very professional laid out system, like, a nice little instruction with the ID, which I believe you need for the app when you register it, installation manual. So you've got something for the end user, something for the installer.
Yeah, that's right.
This is where it all gets fun. So maybe I'll take a couple of cables out first. So this is the HotBot itself. Where would the HotBot be installed?
This is installed alongside your electric water heater. If you open up the device, you'll see there's power terminals inside there. So you cut the power supply to your water heater, and you wire those into the terminals. That will go in the two bigger holes on the right there. The smaller holes on the left, those are for a variety of sensors that plug into the HotBot using basically telephone jacks, so very easily, and then clip onto various parts of the water heater. For example, we measure the temperature of the water going into the heater, the temperature of the water coming out, the temperature of the water inside as well. For an easier view, I've got an open one here. So you can see what it looks like on the inside with the power splicing and then the sensor inputs over here.
Now, one of the things I liked was the very simple explainers right on the actual label outlet. So this is to monitor the temperature of the outlet. And I've never seen a connection like this. This is great. It just clips onto the copper pipe and is directly thermocoupled onto it.
Yeah, that's right. We spent a lot of time innovating in our sensors, both in terms of the performance of the sensors themselves and the ease of installation. With all of our products, we try to follow the principle of poka-yoke, which basically means make it as intuitive as possible to do the right thing. And so, for example, we don't expect installers to trawl through a long installation manual figuring out how to install each sensor, but rather on each sensor cable, we include instructions for that sensor. So if you turned over that yellow label, for example, you'd see a little diagram on the other side with a couple of points on how to install the sensor. That's super valuable. It means that installers do it right the first time, but also if somebody comes back to site and encounters the system and is not familiar with it, they at least have knowledge of what to do and how to replace it correctly. In terms of the sensors itself, sorry, go for it, Glenn.
I was just going to say you've also provided both a visual and a text explainer, which is great. Depending on the literacy of the people using this equipment or their particular language background, it's really self-explanatory with those pictures and the color coding. So this is this is a little thermostat which you would poke into the body of the insulation around the tank. Is that right?
That's an interesting one, probably the sensor that took among the most R&D to perfect. So in your water heater, you've got a thermostat, which is basically a probe with a temperature sensor on the end. And that thermostat gets inserted into a pocket, which is manufactured into the water heater. So what that sensor does, if you look at the end of the sensor, there's like a floppy copper piece. That's a flexible sensor. So what you do is you pull out the thermostat, you thread that sensor into the thermostat pocket and push the thermostat back in again. The advantage of this is that we are measuring the exact temperature that your thermostat is measuring, so we can provide kind of a mirror of the experience that the water heater is experiencing, but also that we have now a fallback, that if either of these systems fail, the other one can still take control and ensure that the user remains protected.
All right. So actually having all the sense information is pretty vital to get from a safety and performance point of view. So this is the cold inlet, blue meaning cold. Same thing. It clips across the pipe going on the inlet, and it's got the RJ11 or 12, is it? Connector.
Yeah, it's a 12.
RJ12 yep. And it's color coded. I noticed inside the unit itself. There's color coding on it. It really is very, very straightforward to install, I can think. This looks like a power cable. What's this one?
Yeah, that's exactly it. It's a power cable. So when you're installing a HotBot, you're typically unwiring the power from the water heater, wiring it into the import of HotBot, and now you need an additional cable to go from out of HotBot back to the water heater. So we provide a length of cable to make that easy so that the installer doesn't have to go scrambling for spares themselves.
So this also powers the HotBot itself?
Well, that cable is typically, it directs power from the HotBot to the water heater. The existing line to the water heater will be moved to the HotBot to power the HotBot.
Yep. And there's some cable ties and some screws. I actually opened it already and the screws all fell out. So you provide mounting solutions as well for this unit because it's got some mounting points on the side here, which you can screw it to a wall, I suppose. So this is going next to the tank within range of these cables. It intercepts the supply going to the tank, uses all the data it can collect from temperature of inlets, thermostat and outlet, and then uses that to create the best outcome for the end user.
Exactly. Yeah, so I mean, a few points on that. Firstly, on the mounting, what's quite interesting about water heaters in South Africa is most of them are in the ceiling void, um, typically above your living room or something like that. And so when they burst, it's awesome, and they flood your whole house. Well, if the drip tray is not working. But what that means is that when you're mounting these things, there's often trusses in the roof against which you can mount them. And so that's why we've designed this cable tie mounting method. So we provide giant cable ties. You can literally mount this thing in 5 seconds flat, hopefully to enable the installer to do a quicker job. But we also provide points for screw mounting in case you're mounting it to a wall or to wood or something like that. And then on the point about it being in the ceiling void, that has other implications as well. You want to know when your water heater leaks. So in addition to the sensors that you've shown there, we also provide a variety of other optional sensors. For example, a wetness sensor that sits below your water heater and can detect if there's a leak, and a shut-off valve to close water supply to your water heater to prevent that leak from then damaging your home.
Yes, I saw both those elements or items in your unboxing video that we were talking about before, but not included in this kit. I presume because in Australia, we don't put our tanks inside our buildings. They're on the outside of the building. So leaks is more of a money loss than a disaster.
Yeah, totally. I think that's a much smarter way to do it. Because I mean, according to some of our insurance partners, the resultant damage from these water heater leaks in South Africa accounts for about 40% of building insurance claims. It's a big problem. So putting these water heaters outside is definitely a big advantage. I wouldn't underestimate the cost though, because when you've got a leak, you're not just losing the water, but all the energy that has been put into that water and constantly put into that water as well. If your water heater is on thermostatic control, so you can rack up hundreds of dollars of bills from a substantial leak.
Just for your information, in Australia, the plumbing regulations require a drain and a tray to capture a leak from a tank if it's installed within a building, and you've got to provide a drain that goes to the outside of the building. So apart from a catastrophic explosion, a leak is not a problem if it's installed to code. Yeah.
Brilliant.
But in New Zealand, where I'm from, we put our hot water tanks inside the house, and we call them airing cupboards because it's where you put all your linen and sheets and things to keep them nice and not get damp. So yeah, in New Zealand, it's probably a similar issue to South Africa, though we also in New Zealand require capture for drainage as well.
Interesting.
Yeah. Now, on that point, so in Australia, if we're installing this unit outside, I'm just hold it up again. You got one. Is this suitable for outdoor installation?
Yeah, it's IP56 equivalent, so it's perfectly splash proof and rain proof. I wouldn't put it underwater. It's not designed for that, but we've got thousands of these things installed outdoors and performing well for years.
Well, that's great because all the entry points are on the bottom and pointing downwards. So I could see IP54 will be easily achieved with this unit. So great. Cool. It's suitable for outdoor
Thanks for that correction. You're right. It's IP54, not 56. That's correct.
Yeah, cool. Okay, well, I'm excited. I'm looking forward to installing one of these on one of the houses here at the co-op where I live. But there's a bit more to Plentify. It's not just about controlling the hot water system by using this device. You can integrate with renewables as well.
Yeah, that's right. So we started with HotBot, with water heaters, because it's the single biggest load in South Africa. It accounts for about 40 to 60% of electricity bills. And it's also a gigantic load internationally. We estimate there's about 350 million of these electric water heaters worldwide. But ultimately, it's not just about driving efficiency. It's about switching source to the best source possible, whether that's the cleanest source or the cheapest source, or whatever else is the optimization you're solving for. And so we've started integrating this whole system with solar as well with our other product called SolarBot, which I know that you've got in front of you as well, Glenn.
Yep, I'll just switch over to that. So there it is. It's the packaging. I think it's really, really nicely done too. It just feels like one of those Apple unboxing experiences. Everything just kind of folds out and presents itself to you. Really nice design too for this unit. So this is the SolarBot, and I see it's got some antennas and a bunch of COM ports on the bottom. Shall we talk a bit about those?
Yeah, sure thing. So as you can see, there are ports for two external antennae. That's because we've got two two modems on this unit. We've got a Wi-Fi modem which talks to your local network, and then a what we call heatwave, which is a proprietary protocol for devices to talk to each other over. In South Africa, it's 868 megahertz. I'm not quite sure in Australia what the band is. We've changed it to. But that allows us to reliably communicate between HotBot and SolarBot, for example, or in a situation where we're in an apartment building for all the HotBots to talk to each other across the whole building. The other ports you're seeing there, oh, sorry. Yeah,
hang on. So the SolarBot wirelessly talks to the HotBot.
Yeah, exactly. So the SolarBot is it's monitoring the state of solar in real time. So it's understanding how much solar you're generating. It's understanding what your battery state of charge is. It's understanding what your optimization parameters are. For example, whether you want your battery charged or you need your battery charged for an upcoming outage or not. And then based on that, it wirelessly talks to HotBot and tells it to turn on when appropriate. If I explain this sequentially, which probably makes more sense, is SolarBot wakes up in the morning. It's started your battery as low as possible, while still making sure that there's enough juice in it for any planned or unplanned outage. It then directs solar to your battery until your battery is full. When your battery's full, it says, cool, battery's full, but there's still solar potential here. And it says to HotBot, time for you to turn on. And HotBot turns on and heats your water till it reaches set point. And then SolarBot says, cool, and pool pump, time for you to turn on, or washing machine, time for you to turn on, and does that all wirelessly.
So it's basically extending your storage of your solar energy, first as electrical energy and then secondly as thermal energy. So you've now got a bigger battery than you thought you had.
Exactly. That's exactly the proposition here, is that we harness the inherent storage potential of the appliances in your home. And in some cases, as you point out, like with water heaters, it's thermal storage. In other cases, like your pool, it's effectively chemical storage, because you just got to pump your pool for a certain number of hours per day, depending on the season. It doesn't need to be at specific times of day. And the chemical balance in the pool is enough to carry it through the gaps in between.
Right. Now, that's the two antennas, the one which connects to your wireless LAN and one which is for communicating with HotBot, or did you say other solar bots?
Actually, other HotBots more than anything else. So a big application of our technology is in multi-family settings. So big apartment buildings and residential estates where they've also got a community solar system or a community battery that the residents are sharing. So in situations like this, we install a HotBot in each one of the water heaters, and then the HotBots coordinate with each other to figure out how to allocate the energy from that community plant to make sure the people who need hot water get it when they need it. And that all happens wirelessly over that network as well.
Wow. Is it like a mesh network?
Yeah, exactly. It's a basic mesh network.
Yeah, so HotBot can talk to HotBot, can talk to SolarBot.
Exactly.
Right. So that would solve a bit of a range issue too. As long as each of those nodes is within a certain range of each other, you've got full visibility.
Exactly. Yeah. So in our testing, we found, I think it's somewhere between 5 and 10 kilometers transmission line of sight with this radio. Wow. Obviously, in a building, you're not going to get line of sight. You're going to have to go through a bunch of walls. But as a result, when you're talking about a couple hundred meters most, this thing performs well. And in a situation like an apartment building where you've got lots of these nodes and they can repeat the messages across the mesh, you get pretty reliable communication.
When you're setting one of these up, is there some indication when you have communication?
Yeah, there is. So our installers get access to an installer app, which allows them to collect data about the installation, which is valuable for training our models, but also gives them feedback on what's working and what's not, and anything that's not working gives them specific guidance on how to fix it. And one of the tests that is run, there's about 7 or 8 tests that we run every time an installation is done. One of those is for communication. And so if the device is not communicating, we'll tell the installer and we'll give them like 3 or 4 troubleshooting steps to try to fix it.
Right. So the installer app is also a fault finding and effectively avoids a lot of support calls by running you through some commissioning tests.
Yeah, exactly. And then our ambition is that nobody leaves site without the bots working. We're not 100% there yet. Obviously, we continue to build the system to enable that. But a big part of that is the installer app and providing this real-time feedback to installers so that they know what's working and can know how to fix it as well.
Now, you mentioned that at the beginning of describing how the SolarBot would work sequentially, that it can see your solar production. How can it see your solar production?
So it interfaces with the inverter in your home. So on the SolarBot itself, you'll see there's 3 ports on there. There is the inverter port, the pass-through port, and the battery port. Actually, there's a 4th port as well, which is the plumber's port. So the one on the left next to the antenna there is the inverter that connects with an RJ12 again, and then plugs into the comms port of your inverter. We provide cables for all the compatible inverters that we support at the moment. It's generally just a plug and play via a DB9 cable or an RJ45 into the inverter. That allows us to read the registers of the inverter and gain all that context about what the system is doing and using that to make control decisions. The next port over from that is the pass-through port. So the pass-through port here, you can plug in the existing dongle that comes with your inverter. Often these inverters have these Wi-Fi dongles so that you can view the data on an app. So with that port, again, we provide an adapter. You can plug in the existing dongle, and it means that you can use either the Plentify app to manage your system, or if you want to go old school, you can stick with your inverter app. It also means that when your inverter needs to send firmware updates, it can do so, because typically that happens via their native dongle, and we pass that firmware update through to the inverter. The next port over from that is the battery port. So here you can plug directly into the battery management system. There's no public features that we've got on that so far, but there's some exciting stuff to come there. And then the final port is Plumbus. So Plumbus is a sneaky reference to a show that we all like here at Plentify. Maybe some of your viewers will recognize the name. But it's basically a wired expandable interface. We can plug anything in there and have it work. And so we've got a whole bunch of dongles we're going to be releasing over time that will expand the functionality of SolarBot. You'll see on HotBot, it's also got a Plumbus port. And similarly, there's a bunch of dongles coming for HotBot to make it work even better.
Wow, this is a very clever little device. And it communicates through the Wi-Fi through to the app. So the end user has an app as well. So there's an installer app and an end user app? Yeah,
that's right. We've actually got a variety of apps and interfaces for our various audiences. So we've talked about the installer app. I mentioned now the user app, which helps you see the power flow in your home. It helps you understand how much of your home is being driven by the solar versus by the grid. And it gives you insights into how you've sourced and used energy over time, but also really cool, how much solar you've generated relative to how much you should theoretically be able to generate if you were able to harness all of that solar. In a place like South Africa, where feeding back to the grid is not common, this is really important because there's nowhere for that energy to go if you're not using it in your home, and it gets curtailed. So we can give you an indication of how much curtailment you are suffering. In addition to that, we've got some other apps and platforms too, in particular, a dashboard for our installers. So installers, they have a job to do when they're on site to get this thing installed correctly and deliver the best customer experience possible. But when they get back to the office, they've got another job to do. They've got to operate and maintain this fleet of solar systems that they've deployed across many people's homes. And we provide the tooling and the dashboards for them to do that as well.
Right. Wow. Now, it sounds like this device has some learning algorithms. You described it as understanding how you used hot water, for instance. How does that work?
Yeah, there's a ton of data science that has gone into our product, and it learns in a variety of ways. It learns from your behavior, but it also learns from the operation of your system, and those lessons are integrated into various parts of the product. Probably one of the best examples is what we've managed to do with hot water consumption. So we used to install a flow meter with every one of our HotBots. This allowed us to meter how much hot water you are consuming, which is a really valuable input into our models. We effectively building a digital twin of each water heater, and this is a key input that allows us to understand how to operate it, but also how much savings you are accruing, which we estimate for you in real time. But this is a really expensive sensor. It's about 25% of the installed cost of our system, because you're talking about not just the sensor itself, but a plumber now to come in and cut pipes and install this thing on the line to your water heater. And so we've been over deploying sensors for the last 7 years, with the view to replacing this flow meter. And we've successfully done that now. So with a combination of cheap, non-invasive sensors and some smart data science algorithms, we can predict how much hot water you're consuming with sufficient accuracy to run all of our models and estimate savings for you, ultimately delivering a better performing product at a lower price.
All right. I'm guessing how that might work. So you get an idea of the electrical consumption by how long the element's on for, and you can see the temperature differentials between inlet thermostat and outlet, and you can use all that to sort of basically guesstimate the amount of hot water being consumed.
Yeah, exactly. I mean, there's a little bit more to it in terms of transients, like how those temperatures change over time to identify events and stuff like that. But in general, that is right. I think what's enabled us to do this reliably, though, is just the extent of data that we've collected. We've got billions of measurements of data across many, many thousands of homes, across many years, many seasons, COVID, not COVID, electricity crisis, water crisis. And so have a really, really rich data set of energy consumption under different behavioral contexts. And from that, we can develop a really powerful model.
Now, just going back to the HotBot with a few more questions I thought of, what sort of element sizes can be connected to it?
It's rated up to 30 amps, so you can connect up to a 6 kilowatt element. In South Africa, typically the biggest you'll come across in a residential setting or domestic setting is about 4 kilowatts. I don't know what's it like in Australia.
Yeah, typically 3.6, occasionally 4.8. Given our high grid voltage, a 4.8 kilowatt element consumes more like 5.2. So it sounds like you've got plenty of headroom there with 6. What about when it's, say, you're producing some solar, you're consuming some of it in the home, but you've only got a small amount of surplus. Can it just divert the surplus into your hot water tank?
Yeah, that would be awesome. Watch the space. I know there are other products that can do this. HotBot can't do it yet. So at the moment, it works best when solar is paired with a battery, because it means that if there's excess solar, we can draw down into your battery as well to supplement any additional power needed, or obviously from the grid too. But even better if it's battery, because then it's hopefully sourced from solar originally. And then once the water is hot, we just restore the battery to its full capacity via solar again. So it does put a few extra cycles on your battery, but it's one of the best ROIs you can make on your battery by using it in this way.
Yes. So it's effectively switching the hot water element on or off. I guess you may consider, if your element's very big and your solar's quite small, you might change your element so it's a better match to your solar.
Yeah, I think that would be a great recommendation.
Cool. Yeah, and the inverter pass-through, that I was kind of curious. So I read about it and I thought, pass-through, what's that? So you're actually solving the problem of being only one comms port maybe on the inverter, and it's already taken by a dongle. So you haven't taken away the dongle, you've just added to that functionality.
Exactly. I mean, the dongle often provides really important features, the most critical of which obviously being firmware updates, but access to apps, access to dashboards. These are elements that are often important to users or installers as well. So we don't want to take it away from them, but rather supplement it with even more awesome features.
Now, you've probably got people who are watching this a bit excited about the product. Can you say anything about where it's going to be available?
Yeah, so at the moment we are almost exclusively in South Africa, and we're scaling pretty rapidly over here. We're serving in the tens of thousands of people across South Africa. We are at the cusp of launching internationally as well. We've got a partnership secured with EDP in Portugal to roll this out to their customers there. I wish we'd been there sooner. Hopefully we could have done something to assist them the last week in the big outage in Spain and Portugal. And then other than that, we're really interested in Australia as well. And we're having some really interesting conversations there, and hopefully we'll be in your market soon.
Well, I'll definitely put a link in the description so people can follow up with your announcements on your website. So
Thank you.
As soon as it's available in Australia. But yeah, I'm looking forward to installing it here at the Smart Energy Lab and getting to know the product. So Jon, thank you very much for explaining Plentify's HotBot and SolarBot. And I look forward to seeing them little boxes around Australia.
Amazing. Thank you, Glenn. Thanks for the opportunity, and looking forward to seeing how they perform in the Smart Energy Lab.
Cool. Well, enjoy the rest of your morning.
Great. You too. Or enjoy your evening.
Yeah. See you, John.
Cheers.